As promised long ago, or a few minutes ago in the last video you watched, if you're just watching these back to back, we are going to talk about compound inequalities, which is two inequalities shoved into one. They're really not that bad to do. We follow a lot of the same steps we do for any other inequalities. We just have to do them a couple times. Let's kind of explain with an example. All right, so we're going to do some examples. Example 1, right? And we're going to do negative 2 is less than or equal to x minus 3 is less than 4. So see, we've got a compound inequality. We've got inequality and inequality. So the way we solve this one's actually kind of a one-step compound inequality. And all we have to do to solve the thing is we have to add 3, but instead of being both sides, it's all 3 sides. So we got to do add 3 here and then add 3 over here and then add 3 over here. See, there's 3 different parts. 3 different parts that we're adding 3 to, right, in this particular problem. So we're going to bring down the 3 that we haven't touched. It's by itself. Bring down the x that we haven't touched. It's by itself, which is what we're going for. Yay, that's great. And then we still have less than. 4 plus 3 is 7. And then negative 2 plus 3 is 1. So then to graph the thing, we're going to kind of graph both bits. So I'm going to put my 0 on here. I like to have 0 on there as a reference point, and then we're going to count 1, 2, 3, 4, 5, 6, 7. Now we're going to put a filled in circle at 1. And then we're going to put an open circle at 7. Now x is greater than 1, but it's less than 7, right? And so we're going to shade in between the two circles. That's not bad, right? Let's do another one, which has a little bit different wording. For this example 2, we're going to do y minus 3 is greater than or equal to negative 11, and y is less than, I keep saying that, y minus 3 is less than or equal to negative 8. Okay, so we're going to just solve each one of these individual inequalities, and then we're going to graph them together on the same line, meeting this and condition here. And we'll see an and condition, we'll see an or condition later. We'll see how those are different. All right, so we're going to start by adding 3 over here, and add 3 over here. And this one happens to be the same. We're going to add 3 over here and add 3 over here. They won't always be the same like that. That's not always the case. This example just happens to have them both be the same. So all that's left over here is y, and then that's greater than or equal to negative 11 plus 3 is negative, I almost said the wrong number. How about negative 8, right? And then over here, we have y is less than or equal to negative 8 plus 3 is negative 5. So we're going to draw our inequality. And we're looking for where both of these conditions are true. This one and that one. All right? So we're going to put our 0 point and then negative 1, negative 2, negative 3, negative 4, 5, 6, 7, 8. So negative 5 we're going to mark, and negative 8 we're going to mark. For both of these, we've got filled in circles, right? We're going to do a filled in circle at negative 8. And then a filled in circle at negative 5. really should have checked to make sure this is even going to produce a result first, but y is greater than or equal to -8, so that would be over here, and less than. So where are both of these things true? Well, it's in between them. This is where it's greater than -8 and less than -5. And the equal to, of course, is done because of the circle. Filled in circle, I should say. There's two examples. Let's do another one. Let's do one that's going to look a little bit different. How about this one? This will be example 3. So we're going to do -2m and +7 is less than or equal to 13. Or, not and, but or 5m plus 12 is greater than 37, right? So just like the last one, we're going to solve each individual thing, right? So we're going to, over here, we're going to subtract 7 and subtract 7 over here. This cancels. This one, we're going to subtract 12. Subtract 12, and the 12s cancel. So see, this is, like I said, they don't always have to be the same. Okay, so we're going to bring down -2m is less than or equal to +6. And, excuse me, we're going to bring down 5m is greater than +26. 25. That's much better, don't you think? Yeah, I think so. Seems right to me. What about you? Let me know in the comments below. Going to divide by -2 over here. Remember our rule with the multiplying and dividing by negatives on inequalities. Divide by 5 over there. That cancels. That cancels. And so we're left with m is greater than or equal to. So that's our rule, right? When we multiply or divide by a negative, it flips the inequality. Greater than or equal to -3. And m is greater than 5. So when is this one or this one true, right? So that's what we're going to graph. This or that. So that's the first part of our answer, right? What we're going to graph is that. Right? So we're going to put our 0 point on there. We're going to go down 1, 2, 3 and mark -3 and up 1, 2, 3, 4, 5. And we're going to put a 5 right there. Looks right. Looks good. Then we're going to check before I start shading circles, I want to start looking at this or this. So it's greater than -3. So that would be that direction. It's also greater than 5. So if the answer was and, if this said and here instead of or, we would only shade here and over, right? Because it would have to do both of them. But since it says or instead of and, we're going to shade both of these regions. So it includes the -3, and then we're actually going to go ahead and just shade straight through the 5 because it's this or that. So we get this entire region shaded. Often, not always, but often when we have an or, it'll be a larger solution set than if we have an and. Well, pretty much always, actually, especially if we include the infinite ends of things. Not always, but very often. All right, so that is compound inequality. Sometimes they'll have and or, and sometimes they'll be like that example 1 where we have 3 sides to do stuff to instead of just the 2 sides. And that's all there is to that. We've got a couple more lessons in this unit. We'll see you for those. And yeah, you can see what else we're doing at emberlearninglabs.com. Hit that subscribe button. It'll help us be able to continue to offer these to you for free. And a like wouldn't hurt either. Thanks. Bye-bye.